Hi there. Today's lesson is going to be over Chapter 13, Big Data Basics, describing samples and populations. Let's jump in. So today we are going to have three key takeaways from our lesson. The first is to differentiate inferential statistics, descriptive statistics, and sample statistics. The next is to identify the basic descriptive statistics used to analyze data and make basic inferences about population metrics. And finally, we're going to define the central limit theorem, and I'm going to give you an example of the central limit theorem in practice. So let's get started. The first thing we are going to cover are some basics about statistics. This will give you the background knowledge to help you understand the statistical procedures we will conduct in Excel. There are two applications of statistics. The first is to describe characteristics of the population or sample, and we will do this through descriptive statistics, that is, numerical measures used to tell about features of a data set. Now, nothing in descriptive statistics can be used to make any generalizations. In descriptive statistics, measurements such as the mean and standard deviation are stated as exact numbers, and those exact numbers are referred to as sample statistics, that is, measures computed only from the sample data. The next application of statistics is to generalize from a sample to a population, and this is done through inferential statistics. Inferential statistics allow inferences about a whole population from a sample, and we're making judgments about the population whenever we're doing this. So researchers, whenever they use inferential statistics, they use that to examine relationships between variables within a sample, and then they make generalizations or predictions about those variables and how they will relate to a larger population. So whenever I show you the 95% confidence interval in Excel with the video for the mean of age, that is an example of an inferential statistic because these parameters are expressed as a range of potential numbers along with a degree of confidence. So we're 95% confident that our range of values, the mean, is between this number and that number. And I show you that in an Excel video, so go and look for that 95% confidence interval video to help you understand inferential statistics a little bit better. Now, the next thing we're going to cover are descriptive statistics, and I'm going to give you a basic overview of those that are the most important, especially for us as marketing researchers. So there are two kinds of descriptive statistics that scientists use. First are measures of central tendency, and those capture general trends within the data and are calculated and expressed as the mean, median, and mode. To preface this, Excel can calculate the descriptive statistics for you. I provide a video on how to do this in Excel, so check that out if you haven't already. One of the most common measures of central tendency is the mean, and the mean is also referred to as the average. So this is where you sum up all the observations for a particular variable, and then you divide that number by the total number of observations in your data set. Now, the mean can sometimes be misleading, particularly when we have extreme values or outliers present in our data. And that's where the median comes in. The median is the middle value in a list of numbers, or it would be considered the midpoint or the 50th percentile. Whenever you're conducting or calculating the median by hand, your numbers would need to be listed in numerical order from smallest to largest. However, whenever you're using Excel or another statistical package, you do not need to do this. The statistical package would conduct all of this for you. The last measure of central tendency that we're going to talk about is the mode. And the mode is the value that occurs most often in your data set. Now, if there is no number in the list that's repeated, then there is no mode for that list. And there's an example of this in our data set that we use for case 13.1, current sales. Current sales, there is no mode because there are only unique values in that variable. The next type of descriptive statistics that we're going to talk about are measures of spread. And measures of spread refer to how the data are distributed and relate to each other. Measures of spread are often visually represented in tables, pie and bar charts, and histograms to aid in the understanding of the trends within the data. The simplest measure of spread is range, and range is the maximum value minus the minimum value. So as you might be aware, the range does not take into account all the observations. It only indicates the extreme values of a distribution, hence the maximum and the minimum values. Thus, a researcher may also be interested in the quartiles of a variable. And the quartiles are subgroups that are formed within a data set when all the values are divided into 4 equal parts across the range. So this is how a quartile or a range of values would be divided into quartiles. The first quartile or lower quartile is the middle value of the lower half. The third quartile or the upper quartile is the middle value of the upper half. The median represents the second quartile or middle quartile. And if we wanted to calculate the interquartile range, we would use the third quartile and subtract the first quartile from the third quartile. Another measure of spread is frequency distribution. Now, in one of the Excel videos, I show you how to conduct a frequency table or create a frequency table in Excel. You could also conduct a frequency distribution using a histogram, and Excel allows you to do this as well. The last measure of spread that we're going to talk about is standard deviation. And in comparison to the previous mentioned measures of spread, standard deviation takes into account all the observations in a data set. And it is the square root of the variance. So both variance and standard deviation are very important and can be calculated very easily through Excel, but they're a little bit more difficult to calculate by hand. That's why I'm not showing you the formula and how to do all those calculations, because Excel and other statistical packages already do these for you. The next thing we're going to talk about are the normal and standardized normal distributions. Now, the normal distribution is also known as the normal curve or the bell-shaped curve. And almost all, 99% of its values are within plus or minus 3 standard deviations from its mean. The standardized normal is where you have a normal distribution with a mean of 0 and a standard deviation of 1. To obtain a standardized normal distribution, you would need to standardize all the values in your data set, and I have an Excel video that shows you how to standardize your values in Excel. This is really important whenever you have variables with very different means and very different standard deviations. For example, in the current cells of case 13.1, the mean and standard deviation are much larger than the age or experience of the cell's representatives. So in that case, we may want to standardize our variables to have a better understanding of the relationships between age and current cells or experience in current cells. The last thing we're going to cover today is the central limit theorem. And the central limit theorem states, as the sample size increases, the distribution of the mean of a random sample approaches a normal distribution. And this works regardless of the shape of the original population distribution. So you could have a population distribution that is right skewed, left skewed, but whenever you have a large enough sample, this would turn into a normal distribution. And the normal distribution is important for us whenever we're conducting our statistical tests and procedures. So having a normal distribution is something that statisticians really want to have whenever they're conducting these statistics. However, in most cases, if it's as close to normal as possible, that will work for whatever we are trying to accomplish as marketing researchers. An example of the central limit theorem is, imagine if you were a marketer for a cat food company and you want to know the average age of cat owners in the United States. The researcher would then gather data from a representative sample of U.S. cat owners and then extrapolate this average age from the sample to the population. The central limit theorem states that if the sample is large enough, its average age will be similar to the average age of the entire population of cat owners. The researcher could then use this sample as a basis for calculations about the entire population of cat owners. So that's it for today's lesson. For next time, we are going to be covering Chapter 14, Basic Data Analysis. I encourage you to watch the Excel videos that I have provided on my YouTube channel. And if you have any questions, email me at kt.manus@ttu.edu. Thanks. Bye-bye.